So this is my Docker running. Now I would like to start the Minikube. How many of you have done with your cluster setup? Are you going with a Minikube or a cluster with KubeAtom? Any inputs? Would like to hear about your cluster setup.
Yes, ma'am. I tried to set up, but I mentioned in the group, like sometimes while giving the kubectl get nodes command, I'm getting the error, and sometimes it's showing the master node or rocker node.
Your kubelet should be running. Only once your kubelet is running, you will be able to connect your cluster.
Yes, right. It's running only. I checked it, but most of the time it's showing the error only. So I can't able to proceed after that.
It would be something with the cluster setup. I think you command master node. I'm getting this error. So some steps might be like messed up. How about have you tried with a Minikube setup?
No, ma'am, Minikube I haven't.
So in case if you are facing any issues, don't stuck up there with those setups. You can get started with your Minikube setup.
Okay.
Mm. So I just want to keep all my manifest files here. You can just use any folder, any path is fine. Okay. So, okay, we have created pod stay through the imperative command, right? Today, let's go ahead and create a pod using a manifest file, using a declarative approach, the approach used in reality. So let's create a manifest file. Manifest file is written in YAML. You don't have to learn the YAML or by heart it again. We'll be always referring to the official documentation. Kubernetes official page and just go to documentation. This is the official documentation. Kubernetes is an open book exam, be it in your real time or in interview or in the certification. It's an open book exam, meaning you can refer this. Like suppose if you are asked to write the manifest file in the interview, you can definitely ask if you can refer this. But if you can write it like through your experience as you keep on using it, if you are having hands on, definitely you can write the manifest file from top to the bottom, right? Even that was a question I faced, and I could write it through practice, through experience. That's all. But you don't have to memorize it. Actually, it's not mandatory that you should memorize that. So go to pod manifest file. Here you can see pods. And see, this is the manifest file. You can just copy and use it and change the parameters. So there's an impression that this is coding. This is not actually coding. This is not a like we write, developers write the code. This is the format. Every object, I'll explain this here. Okay. So here, if you see API version, kind, metadata, specifications, right? These are the things you have. API version is the standard version of your Kubernetes, standard API version of the Kubernetes. And this is kind of what these parameters are mandatory and fixed. API version means version of your Kubernetes API. That's a V1. Kind of deployment. We are deploying this as a pod. Pod is a REST object in Kubernetes API. Metadata. Okay, some name to your pod, Nginx pod, or I would like to put sample pod. Then specifications indicates what is inside the pod. Inside the pod, obviously containers. Name of the container also I would like to put sample. And the image name is just Nginx so that it will pick up Nginx with the latest tag. That's all. So that's how you can modify it. So the standard parameter, kind is also standard. Metadata gives information about the pod like a name, labels, and so on. For now, I'm just adding the label. Specification indicates what is inside the container. Like this is the name of the container coming from this image, which is running on this port. As simple as that. So how do you apply this manifest file? And also when I run this, one pod called sample will be created. Sorry, with one container in it called sample, which is coming from Nginx image. It will pull this Nginx image from the Docker Hub and it will start a container. So let us run this. How do you run this? Kubectl always. Create, if it is for the first time, create -f the YAML file. You can give any name to your manifest file. This is how you apply it. That's all. See, pod is created. The commands are same like kubectl get pod. You see the pod if you want to see where it is running with output wide. For me, node is Minikube, but if you are running it with a kubeatom cluster, it would be showing the host name of your worker node. Okay. And if you want to see more details of it, kubectl describe a pod. So here you can see when you describe it, right? You can say this is the IP address assigned to the pod and the image name. And here comes the events. First, scheduler scheduled it to the Minikube node. Then kubelet has pulled this image. Kubelet has started the pod, created the container called sample, and so on. That's how you have the pod create. This is very important. Declarative approach is preferred because we maintain versions of this manifest file. We'll push these to GitHub and you can maintain version control them. Got it right, all of you? Any questions here before I go on for the next part? Good to go? All right. So coming to this part now, what if I want to scale them to 10 pods? I want 10 pods. How do you scale them? So do you write this part 10 times? Is that feasible? Is that a sustainable solution? Right? It's not. It's not sustainable. So what you should do, also one thing is, yes, I want to scale them. Second thing is, okay, pod is running, but I cannot access from outside the cluster. So how do you do port forwarding? Or else, let's say I want to implement rolling updates, rollbacks means I will talk about all of those things. So to facilitate all of that, you have another object in Kubernetes API. So let us talk about another object in the Kubernetes API. Till now we were talking about pod object. Now let's talk about deployment object. Just a second. Okay. So we were talking about pod and then deployment, right? These are all objects in the REST objects in Kubernetes API. So this is the very basic or the simple method, right? We don't deploy pods this way. I'll tell you, there were so many reasons. You want to scale them up, you want to expose it to the external, you can do it, but it's more effective with deployment. Another reason is, I'll show you, get pod. Okay, I'm deleting it. kubectl delete pod on and the pod name of the object, sorry, type of the object and name of the object. Type is pod, name is sample. Okay, so let us create the deployment object. See, I deleted the pod. You don't see it again, right? There were no resources found. You don't see it back. A pod is nowhere available, right? You don't see this. Okay, so it doesn't come up. But if you want, by some, let's say by mistake, I have deleted it. You want to pod come up by itself, right? That's a resiliency feature of Kubernetes cluster. So if you want to do that, even deployment is the object which helps you. Let's look into it. Let's create, I'm creating another manifest file, deployment.yml. The same pod, I'll deploy it through deployment object. You can imagine deployment is like a layer above your pod. Let's go for search this site. And by the way, whenever you are using in certification or in the interviews, you should go only through the official Kubernetes documentation, not the blogs. See, you will be seeing some blogs, some other content available. So make sure you are picking up the right page. Okay. So deployments and the deployment manifest file. You can see, read over so many use cases, lot of things over here, and I have got the manifest file. So first let's look into this. If you see here, like I told you, API version is the mandatory parameter. Deployment is an advanced object in Kubernetes API. It's not available in V1, it's available in apps V1. Kind is also mandatory parameter. This time kind is deployment. I told you, right? Every object will have metadata and specification. Metadata deals with information about the object. Specification deals with what is inside the object. So name of the deployment, let's say I would like to give the name as deployment. And some labels. Labels are key valued pairs. You may give any label of your choice. I would like to give label app is V1 or app V1. Okay, that's a label I'm giving. And number of replicas. See, this is how you can have scaling. Let's say I would like to start with 2 replicas of pods. Okay, and then selector labels should be having the same labels as the pod. And here you see template. Template is, let's say, a blueprint or a copy of your pod. You can see this is nothing but your pod manifest file, right? So this is nested into this deployment object. Like I tell you, it's a wrapper, it's a cover, right? So your pod manifest file is wrapped around this sample. And here I would like to use my own image. Of course, this is public image. Deploy colon v1. Right, I'll show you that image, but this is the one I want to deploy. When you deploy this, what happens, when you run this, a deployment object will be created. Imagine that's a virtual object. Okay, that's like a wrapper around your pod. This deployment object name would be deployment. Whenever you create a deployment object, by default, a replica set will be created inside, and this replica set name will be prefixed with the same deployment object with some suffix. Within that, you will have a pods. What are the specifications, details of this pods? That comes from this template. Template is a copy. Okay, this metadata is of a pod metadata. This specification is of pod specification. Whereas this metadata is metadata of a deployment object. This specification is a specification of a deployment object. Means pod is nested within deployment object. Every pod follows this template. Every pod is coming from that particular deploy v1 image, and they are running on port 80. You may scale, increase the number or decrease the number. Every pod follows the same template or the copy. So this is how. And by the way, your pod name will be prefixed with your replica set name. My replica set name is deployment 1xx, and each pod will be having a different suffix like this. Making sense? Is this clear? I'll show you, okay, with the hands-on, I'll show you what are all this, where are all this created, but that's a manifest file. Now, get pods, nothing. Okay, let us apply. For the first time, you can is create, kubectl create, or apply is also fine. Manifest file name, done. It says deployment created. Okay, for a while, let me close this. kubectl get deploy. See, that's a deployment object name. It shows two replicas within this replica set. Do you see it is prefixed with the deployment object name? Within that, you will have the pods. Pod is prefixed with that replica set name. Making sense? Hierarchy. Within the deployment, you have replica set. Within the replica set, you have pods. Is this much clear, everyone? Is that clear for all of you?
How many parts running inside me? We have to specify.
Here we are specifying replicas too. So two pods.
Okay.
If you want to scale out, change the number, save the manifest file, reapply it. Same hierarchy. Deployment object doesn't change. Replica set also doesn't change. Within that, you will have the pods. 3 pods would be spread across the available worker nodes. Each one assigned with this IP. 3 pods. It came up new pod came up within 11 seconds.
So without delete, we can able to do like a replica. We need to improve the, more parts, right, ma'am?
Correct. Also, I told about resiliency, right? Let me delete one pod and see what happens. I'm deleting this pod. Something went wrong, a pod is gone. Do you see that immediately another one came up within 2 seconds? Are you all able to see that? Just wondering, are you able to see this terminal and the font? Legible? Is it legible for all of you? No response for anything, at least to whether you can see or not.
Yes, ma'am, I will.
Thank you. Thank you so much for confirming. So this is your pod, right? This is your pod where it started. This doesn't happen before. Do you notice the difference? When I just deployed through the pod like this with a kind pod, if I delete the pod, pod is gone. Correct? It doesn't came up. This is what is. If something happens, it is recovering on itself, which is the resiliency feature of Kubernetes, which is the most important thing. Because I told 3 replicas, it will make sure it will have 3. If you have deleted it, someone have deleted, something went wrong, it will start immediately a new pod.
But
Hmm.
previously, you are created on different manifest file. That is for
Different
one single. In initial you was created on manifest file, right, ma'am? The
one.
first file.
First.
Okay. Okay. No, actually, in this case, actually we delete the part, but it is not recovered, right?
In this case, through this, it's not recovered. Through
Because
deployment, it's recovering.
okay.
I will apply this also. Pod manifest file. Okay. Pod is created. This is coming from pod manifest file. Means
Yes. Yes.
here not manifest file is not important. Important is kind pod. Okay. So it came up. Now I'll delete it. Delete pod sample. It will not be recovered. See, it's no more. It's not coming back. Understood? Because I deployed it with the kind pod object. Kind pod. Right? But if I delete it, delete pod, because it is started in the replica set. Replica set will ensure, see, pod will be, there will be 3 replicas. Okay, that's how you scale out or scale in using this replicas parameter here. To save it, apply it. Apply -f deployment manifest file. Get pod. See, there were only 2 because I changed the number. Hope this is clear for all of you. Okay, the hierarchy is deployment within that replica set within that pod. You may describe your pod also, describe type of the object, name of the pod, or whichever you want to describe. If you don't put the name of the pod, it will describe all the pods. All the pods means 2 pods right now. So it is describing the first pod, 5 MJ and N6, Then the second pod should also be described here. 77 LMG. Each one has got the events, how they got started. Any questions? Okay. I'll consider this as no questions and you are thorough with this. Coming here.
If we in this pod there are some containers running. So if you face any issue in the containers, the application is not running. So how to debug that?
We'll do that. Okay, we'll come to that part of getting inside the pods. And before that, I would like to show you this one. Hub dot my image, that's a public image. Deploy V1. This is the one I'm using. Okay.
Madam, hello. Hello.
Yep. Yes, please tell me.
Madam, actually, if I'm run the actually if my actually I actually sorry, it was actually the three pod is running. I mean one. I mean, so how I can able to check in? I mean, after description. I mean, how to check the how many parts are running? How to verify?
Here you are seeing, right? Get deploy. 2 by 2, 2 pods.
Yeah, two per ma'am. I mean, I need to elaborate. So now one first one part, second part. So those things how I
Describe the
can
pod.
verify.
Describe the pod. Describe command is doing it, right? Is that
Yes,
you
yes.
want to say?
Where I can check, ma'am? Here. Can you please highlight?
What do you want to check?
Yeah. If I'm described the part. So where I can able to check the which pod is running. I mean, two pod is running, right?
2 pods are running. You check that with get pods command. 2 pods are running. Here itself you are checking. Why do you want to check that in describe command? Anyway, describe also describing everything. This is the first pod name.
Okay.
All the pods are described here. If you scroll down, second pod is described here. It is showing the status as running. To check the status, you don't have to describe it. Here itself, you are seeing the status running.
Okay.
Describe is to see which image it is coming from. If something went wrong, events will show you. If something it failed to pull the image or it failed to start a container, events will show you. That's where you describe actually.
Okay.
So your pods are running, but are you able to exit outside the cluster? Means can I exit from my browser? Actually, it's running on my laptop, so maybe local host, it's Nginx. So can I do this? Or on port 80, whatever? Is it available? So how do you do that? I can port forward individual pods. Individual, every pod is having this IP key, IP, I can do port forwarding, but you should never rely on individual pods because pods are ephemeral. What is meant by ephemeral? They are not permanent. New pods will be coming up, old pods will be gone. Like I told you, right? I have just deleted it and that pod came up in its place. So you cannot rely on individual pod IPs or individual port forwarding. Then what should we do? That's where comes another object called service object, another object in Kubernetes API. Okay, what is the service object? Service object will have a stable DNS, stable virtual port, which is called the service port. So what we'll do is, I'll create a service object again by writing a manifest file and tell this service object not to get attached to the pods with the IP address, but get attached to the pods with the labels. Means I'll tell, okay, service object, please go and attach to the pods, whoever having app is app v1. Then it will search, let's say now 2 pods. It goes and attach to the 2 pods. Tomorrow the second pod is gone, new pod came up, but it will have the same labels, right? So labels are quite powerful and very important. They work like a glue, they work like identifiers. Service object will search for the pods with this label and goes unattached. And service object will have a virtual port. So you hit any node in the cluster, node IP in the cluster with that service port, let's say whatever port, you can see your service. You can access the service, but that is served by the underlying pods. Whatever pod number of replicas you have, they'll be standing in the queue to serve the request coming to this URL. Tomorrow there were 3 pods. 3 pods will be standing in queue. Always the healthy pod will be serving the request. So that you are not depending on the pods, individual pod IPs. A new pod may be coming up, it's gone, your service still remains the same. The practical demo will help you better. Let me create another service object. You may give any name to your manifest file. Okay, I'll give this as service1.yml. Also would like to rename this just because later on I'll be creating multiple of them. Okay. All right, so coming to service object. Again, how do you have the service object? Go to your official documentation and you can get the manifest file. If you are using it for years, you would be writing them line by line. You will get used to it. Okay, see again API version, service, metadata. Means service can have some name. This is its own label. Okay, this is optional. Service can also have its own label. Every object will have name and labels. But this is important. This is important because selector tells it should select, it should get attached to which pods with the pods with this label. This both can be different. Label of service can be different from its selector's label. Here in this case, I am writing same. And port where container is running and to which port you want to forward to. Some port on the host, that's called node port. And service type is node port type of service. We can be using different type of services. I mean, there are different type of services which we'll look into. But this is what, and when you describe the pods, you can see the labels. Okay, this is where you see the label. Okay, if you want to see how many of them are there, pipe grep labels. See, right? Or pipe grep app. Right, you can see like 2 replicas. So service object will get attached to those 2. Whether a new pod came up or old pod or you scale up, that's how it works. Let me create a service object. Apply -f service. kubectl get service will show you all the services in the cluster. This is the default one, ignore it. This is the one we created, 30 forward to 30,001. But before that, you can describe any object. Describe a service 1. See, labels of the service. Select or label. Endpoints is important. This is the endpoint of each IP. Sorry, IP of each pod. Get pod with output wide. See, 128, 130 pod IPs. So it got attached to 2 pods. If you want to see only the endpoints, get EP for service 1. Do you see that? And it is exposed to port 30,001, right? And one more thing, this is called service port. This service port should be in the range of 30,000 to 32,767. So within that range, we can give anything. If you don't give, it will take of its own. It will take port of its own choice. Maybe this port might not be available on Mac. That could be the reason if you don't see. Let me try again, 30,001. One more thing. One more thing we have to do here. If it is a Minikube, let me show you. you have it on the Minikube on the same node, right? So if it is like a cube atom cluster or anything, you can directly access. But here you have to run something called, you can run here itself, or else I will run here. You have to do kubectl port forward. Port forward, you have to do this explicitly. This is an additional step on only Minikube. kubectl port forward service name is service1, and the port is host port is 30,180. Right now you should be able to see this. Okay. That is an additional step for Minikube because it's on the same node. You are getting me, right? Earlier it was two separate EC2 instances. So on the worker nodes you can exit. Here the Minikube node itself, it's like a container which is running on the same node. So you have that additional step of forwarding. Right? On 30,000 you can see this. This is my application deploy behavior. Understood everyone? Yes or no?
Didi,
Any
can you show
questions?
the command one more time?
Which command? Okay.
Port forwarding.
Forward command. kubectl port forward service/service name, host port, and the container port.
So this command you run on your local, right?
On the same Mac.
Same.
Here also you can run, but I should keep it running. If I close it, I can't access the service. So that's why I'm running it on a separate terminal.
Okay.
And I'll show you here an interesting thing. Let us scale the deployment. New pod will come up. Right, let me scale up. Apply. Just apply will help you. Apply, deploy one. Okay. Get pods. Third pod is not there. Did I save it? Did I apply this? Oh, okay. It's not applied. Command went wrong. kubectl. Perfect. Now third pod. Now check the endpoint. Service goes and attached to third pod also. You don't have to tell anything. Do you see third IP? Can you all see that? 128, 134, 130. It got attached to 128, 130, 134. So you don't have to do anything. Similarly, I will scale down to 2 again. Apply. Only 2 because there might be only 2 pods. Perfect. Also another thing. New pod comes up, right? So let me delete this pod. Another pod came up, right? It is with the IP 135. Let's see the endpoints. This is important. See, it got attached to 135. Your service will not be, the endpoint is not impacted. Understood everyone the importance of service object?
Yes, sir.
Right, you don't have to, even though new pod is coming up, old pod is gone, new pod came up, it still attaches to all of them because of the labels. That's the importance of service. And as of now, we are using node port type of service. Means, let's say you have 2 worker nodes on one master node. You can access on any node. And of now in Minikube, only one node, so local host. But let me tell you, node 1's IP means worker node, let's say, colon 8001. You can see it. Node 2's IP, colon 8001. You can see it. Node 3, let's say master IP, colon 8001. You can see it. That's what is node port type of service. Means this particular port is open across all the nodes in the cluster. Do you see any drawback with this type of service? Do you see any problem with the service? Any limitations, any downsides of this type? Okay, one thing is which endpoint you will use. Will you use node 1 IP, node 2, node 3, master, which IP you will use? Which endpoint you will share, right? So that's the first question. Of course, first one is security. Because those ports are open across all the nodes, traffic is directly or users are directly hitting the cluster. Security is a concern. Next, which URL? Of course, any request coming to this will be served by the underlying pods. Means load. Load here means requests. Requests coming to this endpoints are shared across all the pods in the cluster. But they are not shared across all the nodes in the cluster because nodes are also not permanent, right? This worker node may be gone. New worker node may come up. So load is not balanced across nodes in the cluster. It is balanced only across pods in the cluster. Load means requests, incoming requests. Incoming requests are balanced across only pods, but not across nodes. Isn't it? So that's a challenge. Security is a challenge. Which URL you will share is a challenge. This is another challenge. And what else? That's all. These are the challenges. So this type of service is confined for test, dev, lower environments. But in prod, and also how do you expose to end users, right? So there comes another type of service called load balancer type of service. This type of service, it will give you a DNS so that you will access it across the DNS. It is not dependent on individual node IPs. Problem is solved, right? But security problem is not solved. Even though it creates a DNS, it's across all the nodes. So that is the challenge. I made a change, and whenever you made a change to your this service type, there will be something called target port, not node port. Target port would be generally same as the, but in this case also internally node port will be used. So I would like to leave this option also because like I told you, it is still exposing on the some port internally. So let me apply the change. Service, get service. The labels wouldn't change, endpoints wouldn't change, but the type is load balancer. It is still accessible. So it's not secure. See, it's still accessible on this port. Right, but you will get a DNS which you can share it with end user. So it is not means only the problem it solves is it is balancing the incoming requests across the pods and nodes. It's not depending on node IPs. That's the challenge it's overcoming, but not this. And also you will not see it actually in reality. IP address will be generated here. You can create this on on-prem servers or a Minikube also, but you need to have a physical load balancer configured at the backend. You know, right? Nginx, HTTPD, HA proxy, F5 load balancer, different types of these all serves as a load balancers as well. How many of you know this? Nginx load balancer, HTTPD, HA proxy, or you have a F5 load balancer, different types of load balancer. You have to configure the backend so that it will spin up an IP address. In our case, it doesn't work. It means you have to configure it. So what we'll do is we'll implement this on EKS. On EKS, it can use cloud native load balancer service and spin up a load balancer, right? So we'll use that. So it overcomes this problem. Load balancer overcomes this problem which node port service has. But still security concern is there because at the backend it's still exposing on certain port. Right? But what we can do is, let's suppose you have two services, front end and back end. Back end, you don't want to expose it. You can use it as like internal to cluster IP service type. Front end can be load balancer. That way only that particular service is exposed. But still the best thing is if you don't want to expose outside, you need communication only inside you have a type of service called cluster IP. Okay, here even though you write it, it wouldn't expose to the nodes also. It's only available within the cluster. Cluster IP type of service. Do you see this? It will not have external IP. It will not be available outside. You can see this. It wouldn't work. Actually, it might be from cache. It shouldn't work. Let me also. Okay, it shouldn't be available. So this is always the best type of service you have to use. Cluster IP type of service. Even though you want to expose it to end users, it should be cluster IP. Then how can you expose it to end users? That's where comes ingress controller, another layer on top of it. We'll come to that part. But these are the three types of services: node port, cluster IP, load balancer. Node port for lower environments, for test dev environments, for quick testing node port. Otherwise, it should be load balancer or cluster IP. Load balancer on some services and rest of them should be cluster IP. Which of them should be load balancer? Not the one which is facing user, but another wrapper around it, Nginx ingress controller, that should be of type load balancer. These terminology is new and the concepts are new, so you may feel it like complex, but analyze it, write down your notes and analyze from your end. Local dev environments for testing purpose. Load balancer. Ingress controller service should be of type load balancer because that will be an entry point to the cluster. Rest of all, either it is end user facing or not, all of them will be cluster IP. Cluster IP means they can talk to one another but cannot be accessed from outside. Means even the front end service will not be accessed directly. It will be accessed via ingress controller. That ingress controller service will be of type load balancer. Am I making sense? That way it is made secure. We will do hands-on on it, don't worry. We'll create ingress load balancer service also. Is this much clear, everyone? Any questions?
Pretty well, you are using the load balancer here, that
Mm,
service. So
mm,
you are using port, target port, and then the node port. So
mm,
first port belongs to the container.
mm.
Node port belongs to the that machine, particular
Right.
host machine. What is the
Mm.
target port?
Target port is generally, it would be the same as the container port. Just that's a parameter which indicates that's forwarded to that particular port. Another
But for
additional
but for the container, we have already given the parameter as port.
target port means to which port it should be exposed to in the host, but it cannot be accessed from outside.
I'm not getting this confusing for me.
Target port is a port which is exposed onto the particular node. Same like node port only, but cannot be accessed from outside. But it is for internal communication.
Uh, can you just create an architecture just like a
Just,
box view?
just ignore this part, okay? Target port should be same as this port. We generally give this. If you don't write this also, there is no problem for it. What I'm saying is this is also same like node port only. Node port means what it is doing? It is forwarding to the same node, host node, right? You can access it from outside. Here also it's doing the same, but you cannot access it from outside. That's for internal communication. You don't have to mention that parameter. Service, go to the service. Target port. You can also read those parameters here. I don't think it's explained here. Types of services. Node port. A service can map incoming port by default and for convenience target the same value as the port. That's all is given here also. Like it is like a same like a node port, but it would be the same value as your container port. That's for internal communication only. 9376. They have given a different port in this case. See,
Yeah.
service targets TCP port 9376 on any pod with this name. The service targets TCP port 97 on any pod. Assigns this service of an IP. This is used by the virtual IP as a controller for that service continuously scans and makes them. Pod definitions can reference the names target port attribute. For example, we can bind target processor pod port in the following way. That is what just mapping 80 to this particular port. You can also give name to the port. So it is just forwarding to this port. That's all. We don't do anything with it. Imagine it is same like a node port, but it's not available outside the cluster. That's all we have with it. So
Ma'am,
just
can you please explain again theoretically? I mean, node port load balancer. What is the difference?
node port is you are node. The name says you are able to exit on every node on the cluster. Okay, load balancer is you'll get a DNS, so you don't have to depend on individual node IPs. Second one, cluster IP cannot be accessed outside the cluster at all. Only for internal communication.
So Priti, here the load balancer type
Mm.
service we are using. So is it different from the load balancer which we are using in the cloud, or it's the same service?
No, this is different. This is Kubernetes object.
Okay.
These services are Kubernetes objects, kind service. These are only related to Kubernetes services, not load balancer service on AWS. It has nothing to do with it. And also how it will work, that's what I'm telling you. You have to create your own physical load balancer, like Nginx load balancer or HA proxy and all. But if I am starting my cluster through EKS service on cloud, then I could use cloud's load balancer as a rather than as configuring a physical load balancer, I can use cloud native load balancer for it. Understood?
So here you're using the ingress controller service.
No, I'm not
Data.
using ingress set. I
Yeah,
just,
yeah. You
okay.
just mentioned like this in front of a load balancer. So are these two related in future, or?
See, please ignore all of that. It's my bad. Please leave this because that is confusing you. Just leave this part. Ingress controller, forget about it. Only let me just revise these things. Node port type of service. Okay, load balancer type of service and cluster IP type of service. Okay, ingress we'll talk tomorrow. Node port is where you will be accessing it on each node IP. Okay, load balancer is you will get a DNS where you can access your, so that it's not depending on individual node IPs, right? So cluster IP is not accessible at all. That's all. When do you use it? Node port for dev local testing. Okay, not secure. Load balancer, where do you use for front-end services, but again not secure. Cluster IP for all backend services. Okay, load balancer can be used for front end, but not secure. No security. Here also no security. Only cluster IP is secure. Okay, then how do you make them secure? Through ingress, we'll talk tomorrow. Got it? Is this clear now?
Yeah.
Right? So, and also this is for front end services. Also here it's not depending on node IPs. So load is balanced across all pods and nodes. Here load is node port, load is balanced only across pods. but depending on node IPs. But load balancer, load is balanced across pods and nodes because you're accessing through the DNS, not the individual IPs. Good, but both are not secure. So how do you make it secure and available for public? We will learn that. And as I made the service node load balancer, this is pending. It should create a DNS. Why it is not creating for us? Also explain. Can anyone why it is not creating for us? What do you have to do? What should you do?
We should give external IP.
You have to configure physical external load balancer, Nginx load balancer. Nginx is a web server, also load balancer, or HTTPD. These are different load balancer services. Like web servers, they also work like load balancers. You have to configure them and configure it to the cluster so that it can use and generate a DNS. Is this much clear?
Yes, ma'am.
Thanks for confirming. So you need this. We don't have it. So it's not generating the IP. Okay, in real time, physical load balancers will be configured. In on-prem also, you have to configure physical load balancers. So for on-prem Minikube, you have to do this additional step, which is an overhead. If you are creating cluster using EKS, managed service, and create load balancer Kubernetes service there, okay, service of type load balancer. In this case, it will use AWS load balancer and spin up a DNS. I'll cover this. Okay, when we start EKS, I'll create load balancer service and will show you how it is using cloud native service. Am I good? Means instead of this physical Nginx or HTTP load balancer, AWS will use AWS load balancer service to spin up a DNS on EKS managed clusters. Good.
Yes, ma'am.
Right. So, but for you, this is all irrelevant for now. Okay, these are all additional things. Ignore this also. If you can't understand, just leave it. Only thing is, understand load balancer cannot be created here. We'll create it on EKS. Once you create it, you will understand why you cannot create here. Okay, so by then you will get a clarity. If you can't understand now, just leave it. Only understand these three things. Node port, load balancer, cluster IP services. None of them are secure. Only cluster IP is secure. But to expose it to end users, we are using load balancer service, but not secure. How do you make it secure? That's where comes ingress controller, which we'll pick up in the next part. Any questions? Any more queries here? Before we go to Nginx, we have deployment strategies. We can start with the deployment strategies tomorrow. These are the 3 manifest files we have written today. Any queries? Anything you need to make clear?
Madam, these labels are, in ourselves only we created, not default. That's right.
These label key valued pairs are, yes, user defined. We can define, but these parameters are predefined, system defined.
Okay, ma'am.
Labels is fixed. This key value pairs are on our own. You can give anything.
Both are same, right? Labels.
The label of the service. Label of the service can be different from the selector label. Selector label is the one by which it selects the pods.
Ma'am,
Yep.
in deployment object, right? We were deleting one node, right? So it will create a replica of that node, or it will create a new node.
Firstly, it's not node, it's a pod.
Oh, sorry, pod. Sorry, pod.
Yeah, replicas. Here you are seeing 2 replicas, right? They are replicas. Each replica follows this template. So copies. Whenever it's spinning up a pod replica, it will follow. Template is, that's what is template. Blueprint, copy, whatever you call it. Another pod with the same configurations comes up. That's why that is also having the same label so that your service object get attached to it.
Then, ma'am, what's the use of deleting?
Which one deleting? By
See,
mistake, I am showing you the demo.
okay.
If something goes wrong in the cluster, if someone deletes it, or by mistake, if something went wrong and it got deleted, there could be so many reasons. Or else your worker node might be crashed. So the
Shall I?
pod, your worker node is crashed. Let me complete that. Your
Okay.
worker node is crashed. Pod running on it will be gone, right? Means that's a deletion. Here I have deleted it manually to show you the demo. Use cases could be for anything. Someone might be deleted it by mistake, or else worker node might be crashed. So pod running on it will be gone. So new pod will be coming up by following the same template. Understood?
Yeah.
Go on, please. Someone is asking.
Shall we assume, I mean, if I want to restart, so I can do, I mean, delete command, right?
If you want to restart.
Yeah, if I want to restart any applications running in the pod, I mean, if anywhere in stuck or hung state, so that time I can able to delete command, right?
You can use delete, but in production, you don't do that kind of manual deletions, right? You will not have access to the cluster at all. Like, of course, you'll have access to cluster, only view access, not you delete, edit, and apply in prod clusters.
Okay, we can't do, I mean,
You can't delete them manually. You will not have that access. This is just for demo I have shown you. Point is when some pod is gone for whatever reason, it will come up. But not that you will delete. But yes, other clusters like dev test, yes, you may be having it as if something goes wrong, you may delete it. Okay. And do that. But if something goes wrong in pod, I mean in prod cluster, if you want to delete it, how do you do that? You will automate those configurations. Automate in the sense, if something goes wrong, you'll have readiness, liveliness probes configured there. If something goes wrong, it will terminate the restarting pod and it will create a new pod. Those logics or the resiliency features are there in Kubernetes. We need to configure them.
And the name you are given here, sample, and above you are given deploy. So what's the difference?
Where is it?
Yeah.
Just go line by line. Container name, almost it's readable. Containers, okay, list of containers. Name of the container is sample. Here, kind deployment, metadata of deployment. Name is deployment. Deployment object name is deployment. Within that, you will have a replica set prefix with this name. Within that, pods prefix with this is a container name.
Okay.
Also, you can see that in the describe pod. If you just go here, name of this pod, okay, because this is the replica set name, right? This is deployment object name. And then if you scroll down, labels. And what you are asking? Name of the container. Come here. Containers, sample container, container ID, image ID, port, host port, status, started time, of ready, restart count, how many times it has restarted, any environment variable set, mount points. Mount points are like volumes, will come to this part. And conditions, like there are different conditions in the pod starting. Initially, it will be like initialized, then ready, container ready, pod schedule, different status happening in the backend, how the conditions change. This could be a in-depth interview question. What are the different conditions a container will go through before it gets started? And token expirations, config maps, default things. These are default configurations. Tolerations, default tolerations. We'll see what is taint and toleration and the events, how it got started. Second part. Explore it, okay? Go through every command, describe it. You can commands, Kubernetes commands are, isn't it? Commands are simple, but the concept is a lot more. Commands are always get, describe, delete. Those things only you have. You can describe any object. First type of the object, name of the object. You can describe deployment object also. It tells you again the details of it, like how many replicas are going to be started. Deployment strategy. Deployment strategy name is rolling update. What is deployment strategy? We'll learn tomorrow. So you will see all of the details. See, like I told you, if you remember, controller is there, controller manager, which will have different controllers. I don't know how many of you revisit the recordings, how many of you memorize those things, but I told you controllers, different controllers, node controller, endpoint controller, pod controller, deployment controller, so many controllers. So it is scaling up, scaling down as we change the number and apply it. 3 from 2, 2 from 3. Replica set is started. You don't have to go into this depth on the day one. First, learn the commands right away, what we did, what we discussed. Then explore these things and you understand them by default. Those are self-explanatory. Any more questions from anyone?
Yeah, Priti, one question here. So, as tomorrow we are going to talk about the ingress. So, earlier there was a concept which we were discussing, like there are two containers of the front end and three containers of the database. So, any container from the front end can interact with the database containers, right? So, suppose the very first container of the database is having an insert command. So, how does the second container of the database know that okay, this some data is already inserted?
That
So,
comes with the stateful sets concept.
okay,
Last
got it.
class in Kubernetes. Last but one or last but two.
Okay.
Stateful sets will help manage the inconsistency.
Okay, sure. Thank you.
Any more?
Ma'am, when we will use EKS?
You can use EKS. See, for all of these things we are doing, we can use EKS. Okay, but EKS is a paid service. So I'll use EKS to show you the features, whichever I can't show you here. For example, load balance service, I can't show you here, right? It's not generating DNS for us, right? I'll show you that on EKS. Also, auto scaling, integrating CI/CD pipeline, those three concepts on EKS.
But it is paid one, right, ma'am? So we can't do hands-on, no?
Anyone interested can do it. It's not like it's up to you. It's individual's choice and preference. If you want to do hands-on, you can do.
Ma'am, but you said for GCP it's free, right?
Yes, it's free on GC.
So can we use
You
GCP?
can, you can. Yes, most
It's
welcome.
kind of similar only, right, ma'am? It's only.
Cluster setup could be different, but one setup, yes, it's similar. But my suggestion, personal advice is to spin up PKS and use it thoughtfully, mindfully. You should use it. Like for me, I and also like how to use it and how you can balance it. I tell you, it will just cost you minimum amount like 150 to 300. That's just is what cost for me because I use it mindfully and I know what I'm using. But if you can do the same way, yes, it would be the same. But again, it's an individual choice whether you will go for it or not. My suggestion is you should go for it so that you will get a real exposure to the real time because, like I told you, majority of the clusters are EKS clusters. In the world, almost 50% are EKS clusters. So it's again up to you. It doesn't make much difference, but if you see the exact real thing you want to get exposure, try doing it. It's up to you. Anything is fine. But that's just a suggestion. Okay.
Ma'am,
Okay,
this
one.
CK paid service, I mean, it is, you said 150 or 300. This is for 1 hour or per hourly?
That's what I'm telling. The number is what I see. Okay, that's not a fixed number everyone would see. It depends on how much time you are using, how much resources you have used, have you left the resources without proper cleaning, all of that matters. Okay, that's a number which I see for me. And yeah, I use it for maybe 3 hours, 3 hours or 2 hours.
Okay.
Priti, for here on-premises services, can we create Nginx? I mean, you were mentioning like we can use the Nginx to create the DNS and
Right.
load balancer. Can we do that at demo?
No, I'm not covering that for reasons that for when you are creating it on on-prem, all these physical load balancers will be configured and provided to you by admin teams. Linux separate admin team is there who will manage the service. They'll provide you. Configuring Nginx, we don't do. Once Nginx is there, creating ingress, it's save in all the clusters. So I'm not going with the configuring that Nginx server. But you can check it over the internet, you will find it. It's just simple setup only, but it takes some time.
So the same host machine should have the Nginx installed within that.
No, separate server. That's another challenge. The separate server is the ideal practice. A separate server where you will have it.
Okay.
And if you have done that, I have configurations for Nginx on the on-prem. It will be almost same, but to test it, the debug it, that's a different story. Let's first complete our ingress, okay? Then you can try it out.
Okay. Thank you.
Whole point is if you are thorough with the concepts, whether it is on-prem or EKS or GKE, whatever it is, you will be through, you will be able to do it. So focus on understanding the concept. Don't get confused with should I do it on on-prem or GKE or EKS. No, focus on you are understanding it thoroughly or not. That should be the focus. I definitely know people get overwhelmed about different environments and would be carried away thinking about it, but don't drain your energy there. Put your energy on the concept, understanding it thoroughly. So given any sort of environment, you can thrive. All right, then. That's all for today. We'll stop here and we'll continue tomorrow. Thank you all. Good day. Bye, everyone.